Greetings. In the last 3 Planet Line tutorials, you've learned how to bring Sketchfab objects into a pre-existing spatial world so that you can add your favorite animals and something about yourself and your home region to the Florida Wildlife Corridor curriculum map with Planet Lines. You've learned how to create your own spatial world using Spatial's online tools, and you've learned how to use Blender GIS and 360 Street View to create a landscape environment and skybox that is geographically based on areas you are most concerned about protecting wildlife in. For example, your own home or school or neighborhood. Now we want to take things further and get into truly detailed and interactive world building. Welcome to the real world, made virtual. Welcome to world creation for ongoing efforts to make the world better. Welcome to my world. This is a world I created that depicts where I happen to live, and I made it in a program called Unity using the Spatial World Building Kit for Unity. And what we want to do is learn you how to create depictions of where you happen to live or places where other animals live that you really care about. We started climbing that learning curve in the last tutorial when we explored using Blender GIS to create a landscape and a skybox. Now we will show you how to take a photogrammetric scan of an area that you make or that somebody gives you and put it and the animals and vehicles and custom avatars into Spatial. Let's zoom out a bit before we plunge in. I mean philosophically. See, in this tutorial, our task is to put all the elements we can muster together in Unity for Spatial. I guess that's why it's called Unity, because we create a unity between these different elements. At this level, you really have to be a jack of all trades and trade in the realm of what we call compositing. Not composting, although that's a wonderful thing to do too, but compositing, where you take skills from every area you've been developing and compose something that employs them all. Audio, video, still photography, 3D modeling, coding, you name it. You really have to be a jack of all trades and develop a collaborative problem-solving mindset. Because while you can use programs like Unity and Blender and Audacity and Spatial to do everything yourself, it's really tough. It's much better to work together as a team. And this journey is not for the faint of heart because the hardware and software and procedures and capabilities are constantly changing and evolving. By the time you learn some of these skills, they will already be outdated, and many of the software and hardware solutions will have been deprecated, gone extinct. But we must press on because there's a larger threat of extinction that we're trying to use our skills to fight, and that's the extinction of our wildlife and the loss of our biodiversity. Some students come to school hoping to learn skills that will one day translate into a job. Some come driven by curiosity, some by passion, and some, like you, with a sense of mission. Our mission is to use these skills to save wildlife. As sustainabilists in training, you may have wondered, is there already something going on that blends Blender and Unity and Unreal Engine and Audacity and video production and AI that I can get involved in tout de suite? That's French for immediately. Something that will motivate me to keep up with the maddening pace of change in production technology? And the answer is yes. There's an ongoing and urgent effort to preserve what's left of Florida's formerly formidable biodiversity. It's called the Florida Wildlife Corridor curriculum, an effort to use every means necessary to get Florida residents and Florida voters and visitors to stop the wholesale destruction of our precious lands and waters. You can learn all about it by going to floridawildlifecorridor.org. Now, sadly, this Saving the World project is one that may never be completed here in Florida because profiting from short-sighted, irresponsible development seems embedded in the psyche of most Florida developers, businesses, politicians, and home buyers, at least for now. So the best that we can do is use our skills in pre-visualization and production to show more salubrious possibilities and give people alternative visions of land use and planning so that they can change their profit model and see how there's more profit to be made making wildlife safe and abundant and living among our relatives, the 4-legged, 8-legged, 6-legged, 2-winged, no-legged walkers of our planet lines. The goal of our project is to transform every neighborhood and roadway into an active arm of the Florida Wildlife Corridor and show those salubrious possibilities. And there's so much to be done. Putting a photogrammetric scan in Sketchfab and Spatial. First, you gotta have a scan. I made mine using my drone and programs called Polycam and Meshroom. These techniques are beyond the scope of this tutorial, which already is the most complicated we've done to date. So let's just assume you receive a scan from somebody who already knows how to make one. For our purposes, they should have given it to you as a GLB file, just like the ones of the Florida Forest Boardwalk and the Florida House and the swamp bucky that we pulled in from Sketchfab in the previous tutorials. I've provided my scan as a part of the Rosebud property for you to get started and follow along with here in the usf.box.com folder. It is the rosebudpolycam.glb file. I've also uploaded it to Sketchfab so you can access it there. Note that the Sketchfab model is slightly different than the one in USF Box because for free accounts, Sketchfab doesn't allow models greater than 100 megabytes, and the one in the USF Box was 101 megabytes. Thus, I went into Blender 3D and edited out some of the extraneous parts of the model. Bringing our own photogrammetric scan into Spatial from our computer. When you downloaded the rosebudpolycam.glb file to your computer, you can upload it into Spatial as an environment. As soon as you set it as an environment, you'll probably find yourself flailing through the air as the environment model flies past you. You need to hit Edit to correct its size and position under a character. Once we adjust the position and size of the environment below our character, we can hit Done. Your character will land on his feet, hopefully, because when you set an environment, Spatial should put a collision bounding box around the object. But you'll notice that you aren't exactly standing on the ground and the environment probably came in the wrong size. You'll now face the tricky task of adjusting the scale of the object to work with your avatar. That will involve trial and error. As in the second tutorial, go to Settings, then Space. Open the Space settings and choose Environment Settings. And now go to the Edit Environment Position and manipulate the scale and the Y value, the vertical position, until you get it where you like it, and then hit Done. Because I created this model from my scan in Polycam, it actually does have collision contours as if the Biodigester Dragon were merely a hill on the landscape that you can climb. So that's pretty awesome. Let's quickly put it in a skybox that I created from the Google map of the region, especially because the default skybox that Spatial puts in has mountains and Florida ain't got no mountains. It would be much better if I could get inside the Rosebud property and take my own 360 photosphere, which we will do next, but for now we can make do with this Google Maps Street View of the area. Open Street View Download 360, the program we showed in the second tutorial, and paste in the URL from the Street View, and then download the resulting image. We will use Blender again to make our photosphere as we showed in the third tutorial. We open Blender, start a new file, get rid of the camera, get rid of the lights, and get rid of the cube, and add a mesh UV sphere, then go to the Materials tab, and then open up the image as an image material for the photosphere. Choose the one of the actual landscape that we brought in from Street View 360. It gets mapped on and then export as a GLB file, including just the selected objects, assuming you've selected the photosphere. And now it is a GLB, and once you've exported the photosphere as a GLB, you can upload it to Spatial and use it, set it as a skybox. Bingo. Once it comes in, you can go to Settings and edit the environment's rotation so that it more accurately reflects reality. Of course, it would be best with a skybox made from a 360 picture taken where your environment is centered. And this can all be tricky since you won't see the skybox when you're editing the environment. And all of this points to the real purpose of this tutorial, which is to show you how to create and set everything in Unity so you can make a perfect match of the entire environment before you upload it to Spatial. And one more thing before we get to that, we just want to show you how you could get your custom photogrammetry model from Sketchfab within Spatial instead of uploading it from your computer. This assumes you might not have access to the USF box and to the original file, but that somebody put it on Sketchfab as I did and made it public so you can find it. We will use upload and replace environment so that you can see how, as we improve our models, we can always go back into our spatial world and upload and replace those improved environments. So here we go. We select from the content menu now instead of from our device. And you can see that now, because Spatial is connected to my own Sketchfab account, the Rosebud Polycam model that I uploaded to Sketchfab is now available to me under the content menu Sketchfab option. There it is. Now we can bring in the model from Sketchfab, but I want to reset its position so that it aligns better with the skybox. Putting in a photosphere skybox from your mobile phone. If you have a phone camera that takes 360-degree pictures or photospheres, you can go around your favorite places and make your own skyboxes to use in Spatial and other programs. I have an Android phone which has the following feature. To get my photosphere off my phone, I simply upload it to Facebook. Then I can share it with friends and we can all view it as a 360 image, scrolling around to see from many angles. And this is particularly cool when you open Facebook on your MetaQuest VR headset. So it's my recommended procedure for starting the process of inviting people to be part of your world. Now, to get it into Blender, please note that if you simply right-click to download it, it won't be unwrapped as a real 360. And so when you put the image on the UV sphere, it won't do a seamless wrap. It'll look like this. There'll be a crease. To get your photosphere out of Facebook as a UV unwrapped material that will map onto the sphere, you download by clicking on the three dots on the right side of the top of the Facebook image and then choose Download. It will download with a long string of numbers as a name, which you can rename to make it easier to work with. You will know if you have a proper photosphere image for a 360 skybox if it appears unwrapped with ends that can be stitched together. See how this end and this end are really the same, just flipped around? Now when you map that image onto the sphere in Blender, it will stitch together seamlessly. You now simply have to check that the material's normals are facing the right direction, in our case inward, so it can be viewed from the inside. To do that, turn on face orientation. If the outside of the sphere appears blue, then it means the face of the material is facing outward, and it won't be visible from the inside in programs like Unity or Spatial, even though you will be able to see it in Blender. Viewed from the inside with face orientation enabled, it will appear red. We want the inside to appear blue and the outside of the sphere to appear red, so we need to flip the normals. Normals are, as in geometry class, the lines perpendicular to the plane. We can make the normals visible so we can see how they orient by clicking on one of the normal view tabs and setting their size. There they are. They appear like little bristles or spikes or hairs. To flip the normals to the inside of the sphere, go into Edit mode and go to Mesh, Normals, Flip. Now when you go inside the sphere, you'll see it is blue, not red, and the normals are pointing inward. It is ready to be exported as a GLB file for Spatial and an FBX file for Unity. So let's bring that GLB into Spatial and replace the skybox we brought in from Street View 360, which was taken by Google Maps from the road and isn't what we need for the environment inside Rosebud. So here's the picture of the Google Map photosphere, and you can see the road there. That's not what we see when we're standing here at all. We don't need to go to settings and replace the environment, just select the GLB file we exported from Blender and bring it into the world. And there it comes in as a sphere. Select the photosphere and click on the custom environment button and set it as a custom skybox. You can see that this new skybox, taken with my phone in the real world from a position near where my avatar is standing, will match much better, even though the biodigester dragons and hay sheds will both be visible as 3D models and as part of the skybox. Now, technically, you should go into a program like GIMP or Photoshop and remove them, but that might be overkill for now. Voila. So, while it isn't by any means perfect, at least these are images of the actual trees and sky and area surrounding the model. And this view is indeed what we do see when we stand up on top of the biodigester dragon on our property able to see the bee area, the solar panels, and the authentic indigenous Lakota teepees in front of the school bus. So kids in particular will find it super cool. Again, with trial and error, you may be able to get the environments and skyboxes matched up better. And this is great for beginners just getting into creating digital twins of real landscapes so you can teach people about your location's role in articulating the Florida Wildlife Corridor. But you're now at the point where we know you'll want to have much greater control over your entire world. And so that's why we want to do everything now we can in Unity Game Engine, and then simply let our spatial avatar explore that pre-made world. Creating your first world in the Unity Game Engine. Let's forget about Spatial for a moment and just focus on recreating our environment and skybox from those two .glb files in Unity, as though we were creating a game for learning about how to make our home and favorite environments more sustainable and conducive to wildlife, regardless of the platform we want to publish it on. You see, Spatial is just a publishing platform so that you can make your games go public. This is how many of us worked before Spatial.io existed as a vehicle for sharing our creations on the web. So let's start by downloading and opening the latest version of Unity, which is what most people will do or have done, and take it from there. So start by downloading Unity Hub from the web. And as usual, you'll have to create a free Unity account. If you're a student or if you earn less than 100K a year from using Unity, it's free. And download the software. First, the Unity Hub software itself, and from there, the version, or actually versions of Unity that you would like to work in, because you'll need several. By the way, and you will hear me say this often, I recommend you get a dedicated SSD hard drive for your versions of Unity and all the assets you want to use in your project, as the files will be huge. You'll want to have several versions of Unity on it and be able to bring your project from computer to computer. Generally, we keep Unity Hub on our main computer and the actual Unity programs and our projects on our SSD drive. You will see a recommended version that is perhaps older than the latest version. The LTS means long-term stability and suggests it has had the bugs worked out. The newer versions may ultimately be better and have more functionality, but won't have gone through rigorous testing. So for starters, stick with the recommended version. Make sure you select the Android SDK option for use with MetaQuest VR. Be patient. It'll take between an hour and 2 hours to get things installed. Then create a new project. I choose the 3D Core because I later intend to use it for Spatial, so I don't need one of the other specialty templates. When the project loads, which can take a good 5 to 10 minutes, you'll see a window like this. I right-click in the Assets area on the bottom and create a new folder next to the Scenes folder for the environment and skybox that we created earlier. Inside that folder, I right-click again and import new assets. I want to bring in the environment and skybox I created earlier. The problem is that Unity doesn't accept .glb files. Oops. So it's back to Blender to do the file conversion. You have two options. The first is to export each file as a .fbx file because Unity does accept FBX files. The second is simply to combine them in Blender and then import the .blend file itself into Unity. No exporting necessary. That is actually the preferred option because then you can go back into the blend file when you need to make changes and it will update in Unity. Here's a picture of the two .glb files imported into the same file in Blender. When I zoom in with the scroll wheel and select the sphere, I can rotate it with R and Z, rotate Z-axis, and position it as I like now. Unlike when we were working in Spatial, I have precise control over the objects and their positions. I resize the sphere to cover more of the landscape as a sky dome. I toggle to the wireframe view to see it better. And now I don't have to do any exporting at all. Unity is made to work with Blender. So now in the Assets folder, I just import this Blender file as a new asset. You can see that it comes in fine. And now I drag that onto the main stage by dragging it into the hierarchy so that it positions on 0, 0, 0. The trouble is that now we seem to have lost the textures. Now to fix that, we need to bring the image textures in that Blender used. Let's start with the landscape. We select it and then go to UV editing. We see when we select the mesh how the polygons map onto the image. We need to download this image and bring it into Unity. In the UV editor, go to Image and Save As and give it a name you'll recognize. Now when we drag that image onto the selected mesh, it will create a materials folder and a material in Unity and apply it to the mesh. Getting the 360 image initially doesn't seem as easy for some reason. When we try the same procedure, it only seems to give us half the sphere and it's out of place. The problem seems to be that Blender put in its own camera and light in the scene, and that's messing us up. So we must delete them. That's better. Now the only problem is that while the skybox is visible from the outside of the sphere, it doesn't show up inside the sphere where we want it. Oops, seems the texture is backwards. So we have to go back into Blender and select the sphere, and as we showed earlier, go into edit mode and then flip the normals, the perpendicular lines that tell Blender how light is interacting with an object. Again, to know if you're getting it right, you need to go to the viewport overlays on the top right of the screen and toggle face orientation. Blue means the normals, the light path is facing you. When we flip them, the outside of the sphere will be red and the inside blue. Now we re-import the Blender file and delete the camera and light. And finally, when we drop the 360 panorama image on the sphere, it comes in properly, viewed from the inside. So now we can build out the rest of our world, bringing in other objects that we want in the game. How about that school bus? It comes in way too big, it seems, and that indicates that our world must be way too small. Because most Unity Asset Store assets, like this school bus, are sized for the default size of a character avatar. That's why I always bring in a car or a bus to help me size my world properly. Since Rosebud has a bus on the property, that's the best object to bring in because it exists in the real world and evokes the idea that we are an educational institution. Now, let's use the scale tool to size the Blender prefab to the right size. We could also have done this in Blender, but the Unity assets are better to use in Unity, so we know they work with Unity. To get more accurate, I also bring in an avatar, in this case a free character controller I got from the Unity Asset Store. Now I want to bring in an animated bear for the wildlife corridor. To get one, I click on the Asset Store tab and it directs me to the online search connected to my Unity account. When I type in bear, you can see many assets for sale. The best option is the Animal Pack Deluxe that I purchased back in 2020 for $5. It contains a bear, and all the animals have animations attached to them. Because I downloaded it for a different project, I own it, but I need to re-download it for this one. Every time you start a project in Unity, you need to re-download and import the assets to it. I already purchased this and own it, so I won't need to pay again. I should find it in My Packages in the Package Manager. We can drag the bear from the pack into the scene. It is a brown bear and we want a black bear, so let's change the color by making it darker by changing the material albedo. And of course, today there are new technologies that will generate 3D objects and landscapes from text prompts using AI. For example, here's a black bear we made in a trial version of Masterpiece X. Since it downloads as a GLB, we have to open it in Blender to make it an FBX to bring it into Unity. So now it needs a texture. We can start with a material color. And then when we bring in our AI bear, he's actually the perfect size. Now, since we've purchased the $5 Animal Pack Deluxe and it has lots of animated animals that actually do live at Rosebud on our property, let's bring in some goats and chickens and the pig. We just go to our project assets and open the prefabs folder in the Animal Pack Deluxe folder and drag our favorite animals into the scene. Now the great thing about creating our scene this way is that we can test the scene using the play button. Hit play, and Unity puts you in game mode, and you'll see the world through the lens of the default Unity camera, and you'll notice that the animals you brought in from the Animal Pack Deluxe are actually moving. This shows us that there aren't any problems with our file. If the game plays without errors, it is generally good. That in itself is a lot of fun and is a reason to start your spatial world in a standard default Unity template, since you can check everything out quickly. You'll find that once we start using the Unity SDK for Spatial, testing takes longer since everything has to be transmitted to the web-based Spatial sandbox and requires a good internet connection. By building your world in basic Unity first, you can avoid needing Wi-Fi connection for a while. You can move the camera in the scene view or go to the game view without hitting play and select the camera in the hierarchy and use the transform sliders to move and rotate it where you want to see the scene. Then when you hit play, the objects that have animations on them will move, and you'll see the scene as if it were a movie. This is the advantage of putting in Unity Asset Store animals that have animations attached. Otherwise, everything would just look static. Since our human animal will be supplied by Spatial, I'll now remove the avatar I put in for sizing purposes. There's so much more we can do with Unity, creating a full-fledged game with first or third-person controllers, multiple moving cameras, for example, but all we're using it for here is to create environments and skyboxes and persistent interactable objects, animals, vehicles, for our spatial experience. So we can stop here for now.